Hello, explorers of the cosmos. Welcome to another journey through the universe. Today, we're going to delve into a fascinating topic, the extreme environments of our solar system. Get ready to discover alien landscapes, colossal volcanoes, raging storms and oceans hidden beneath layers of ice. Throughout this adventure, we'll explore how these challenging environments help us understand the history of the solar system, the evolution of planets, and the possibility of life on other worlds. We'll embark on a journey through time, searching for clues about the formation of the solar system and the processes that shape the diversity of planets and moons that comprise it. Our first stop is Io, Jupiter's moon that is home to one of the most hellish landscapes in the solar system. Imagine a world covered in constantly erupting volcanoes, spewing lava and sulfurous gases kilometers into the air. This intense volcanic activity is driven by Jupiter's powerful gravitational pull, which causes an extreme tidal effect on Io, generating enough internal heat to keep its interior molten. Io is a true natural laboratory for studying planetary geology in action. Its volcanic eruptions release material that contributes to the formation of Jupiter's magnetosphere, a gigantic magnetic shield that protects the planet from solar radiation. This interaction between Io and Jupiter helps us understand the complex dynamics between planets and their moons. Our next stop is Venus, the planet that most resembles Earth in size and mass, but which hides a dark secret, a hellish climate. With temperatures exceeding 400 degrees Celsius, Venus is the hottest planet in the solar system. Even though it is farther from the Sun than Mercury, Venus' atmosphere is composed mainly of carbon dioxide, a greenhouse gas that traps solar heat, creating a runaway greenhouse effect. This dense atmosphere also exerts crushing pressure on the surface, equivalent to being 900 meters deep in the Earth's ocean. Venus shows us the power of the greenhouse effect and serves as a warning about the dangers of climate change. Mars, the red planet, has fascinated humanity for centuries. Its reddish color, visible to the naked eye, arouses the curiosity and imagination of scientists and space enthusiasts. Today, we know that Mars was once a warmer, wetter planet with rivers, lakes, and oceans. But what happened to this lost paradise? Robotic exploration of Mars has revealed evidence of a past with liquid water and possibly conditions favorable to life. However, Mars lost its atmosphere over time, transforming itself into a cold and arid desert. Comparing Mars to Earth helps us understand the fragility of planetary environments and the factors that can lead to the loss of habitability. Titan, Saturn's largest moon, is an enigmatic world, enveloped in a dense atmosphere of nitrogen and methane. This organic-rich atmosphere hides a surface sculpted by rivers, lakes, and seas of hydrocarbons, a unique setting in our solar system. Titan is a natural laboratory for studying prebiotic chemistry, the processes that may have led to the formation of the first organic compounds in the early solar system. Analysis of Titan's atmosphere and surface could provide clues about the origins of life on Earth and the potential for life on other worlds. Jupiter's moon Europa holds a fascinating secret, a vast ocean of salt water hidden beneath its icy crust. This intriguing discovery makes Europa a prime candidate for the search for extraterrestrial life in our solar system. The presence of liquid water, a fundamental ingredient for life as we know it, makes Europa a prime target for space exploration. Future missions plan to drill through the ice and explore Europa's subglacial ocean, searching for signs of biological activity and organic compounds. The discovery of life on Europa would revolutionize our understanding of life in the universe. Pluto, the dwarf planet demoted in 2006, is a distant, icy world located at the edge of the solar system. Despite its small size, Pluto has proven to be a geologically active and surprisingly diverse world. The New Horizons mission, which flew by Pluto in 2015, revealed mountainous landscapes, icy plains, ice volcanoes, and a thin atmosphere composed mostly of nitrogen. Pluto shows us that even in cold regions far from the Sun, planetary geology can be dynamic and fascinating. Robotic exploration has been instrumental in unlocking the secrets of the solar system's extreme environments. Space probes such as Cassini-Huygens at Saturn and Titan, Juno at Jupiter, and New Horizons at Pluto have collected valuable data about these distant worlds, expanding our understanding of their formation, evolution, and potential to support life. Robots can withstand extreme temperatures, pressures, radiation, and chemical environments that would be lethal to humans. Robotic exploration allows us to study these challenging environments safely and collect data that would be impossible to obtain otherwise. Human exploration of extreme environments in the solar system, such as Venus, Io, or Pluto, presents immense challenges. The extreme conditions in these places, such as scorching temperatures, crushing pressure, intense radiation, and corrosive atmospheres, would pose a lethal risk to astronauts. The long space travel required to reach these destinations would also expose astronauts to risks such as cosmic radiation, microgravity, and prolonged isolation. Current technology does not yet allow for the creation of self-sufficient habitats in such hostile environments, making human exploration of these places a challenge for the future. The discovery of extremophiles on Earth, organisms that thrive in inhospitable environments such as volcanic hot springs, acidic lakes, and frozen polar regions, has challenged our understanding of the limits of life. If life can exist in such extreme environments on Earth, why not on other worlds? The possibility of microbial life in environments such as Mars, Europa, or Enceladus is an open question that intrigues scientists and drives space exploration. The discovery of life on other planets would revolutionize our understanding of life in the universe. The extreme environments of the solar system offer us a window into the past and the future. By studying them, we can unravel the history of the formation and evolution of our planetary system, understand the processes that shape the diversity of planets and moons, and seek answers to fundamental questions about the origin of life and the possibility of life on other worlds. Robotic exploration has been crucial in unlocking the secrets of these challenging environments, while human exploration, still a challenge for the future, is a dream that drives our search for new knowledge and our fascination with the cosmos. If you are interested in astronomy, space exploration, and the search for extraterrestrial life, subscribe to our channel to follow the latest discoveries, space missions, and debates about the future of humanity in the cosmos. Leave a comment with your impressions of the extreme environments of the solar system and share this video with your friends. We thank you for joining us on this journey through the extreme environments of the solar system. We hope you have been inspired by the beauty and mystery of our universe. Until next time.